Hi, my name is Brandon, and today I present my project of understanding of statistics, and I will talking about the binomial distribution probabilities. First of all, we need to understand that there are two types of random variables that it could be our data. The first one is the discrete that takes and countable number of outcomes that could be infinitive or finitive, and it is expressed with these brackets that we could see in the screen, where we have 1, 2, 3, 4, 5, 6, 7, 8, and 9. So here we only could take in account these exactly numbers that we see in these brackets. And the next one is the continuous that takes only any points in any interval that we have. As we can see in the image, we have a 0, 0 and 1. And here we could take any number that it's in this interval, like 0 0.02, 0 0.090, and so going on. So we could choose a lot of numbers. So this is count as a discrete random variables that they are uncountable. So knowing this, we will begin with the characteristics of the binomial distribution experiments. That the first one is that they are discrete by random variables. As the first point says, the experiment consists in some number of trails. And in these trails only could be two types of results. The first one is the successful, and the other one is the wrong, the failed. And this probability, it's important to understand that the probability of success will be constant in all the trails, in each trail. Then it's important to understand that the trails are independent in each other. They could happen in the same time, but they are independent. Each one doesn't affect the result of the other. Then, knowing this, we will continue with some examples to understand how can we identify these binomial distribution problems. The first one says, you observe the sex of the next 15 children born at a local hospital. X is the number of girls among them. So here we could think that it's a binomial distribution because there are only two results, I'm sorry, that could be that the babies will be a girl or the babies could be a boy. The next one is a car manufacturer chooses one car from each hour's production for notated quality inspection. One variable record is the count X of finished defects that could be simple rips, etc. in the car's paint. So here the same problem told us that could be more than one result in the effects of these cars. So we won't have only two results, like success or failure. We could have success, but we have many different forms to fail. So it is not a binomial distribution. And the final, the pool of the potential juniors for a murder case contains 100 persons chosen at a random from the adult residents of a large city. Each person in the pool is asked whether he or she possesses the death penalty. X is the number who say yes. So here, when it says X is the number of who say yes, we can conclude that we only have two types of results, that the person will say, yes, I do it, or yes, I know, or no, I don't know anything, or I don't know. So this is a binomial distribution. Now, it's important to know that this binomial distribution or discrete distribution could be described in two principal ways. The first one are the graphics, and the second one is by tables. And this is for understanding in a better way how this data is working. The first one, with this example of the rent housing in 2005. Here we can see the table, the graphic, where the probability is in our y-axis, and the number of trails is in our x-axis. And here we could be formed to analyze and present the data. Other form is with a table where where x is the number of trails and the px will be the probability of these trails. And this will help us to find very fast one probability that we want to know. As in the example that we need to find the 8 people, what is the probability that 8 people are waiting in the linear launch? And here is the result. Now, how can we find this probability in this binomial distribution? It is very easy with the next formula that it's P parentheses of x is equal to lower x is equal to ncx P to the power of x parentheses minus 1 minus the probability and x to the power of n minus x, where x could be the number of trails, 1, 2, 3, 4, 5, 100, I don't know. And P is the probability to success, the probability that we will achieve what we are researching. N is the number of trails. X could be the number of success in the trails. And the NX is the number of fails in N trails. Now, it is important to know that the NCX have a special form to find this value, and it's by the next formula that we are seeing here, where it says that NCX is equal to N question and interrogation mark over X interrogation mark parentheses N minus X. Here, this computation could be made by a calculator, and the exclamation mark could be found in the calculator. Then we will see a simple example with numbers, where the problem says us that n is equal to 10, the probability is equal to 0.4, and x is equal to 3. And here, the only thing that we need to do is to compute the formula and plug it the numbers that the problem gave us. Then also we could find the standard deviation of a binomial random variable, and the standard deviation, the mean, and the variance, where, as we can see, the formulas in the slide. Now this is an exercise that we could perform, and it is saying, according to the American Red Cross, the 7% of the people of the United States having blood type O negative, a simple random sample of size 4 is obtained, and the number of X people with the type of is recorded. So here we can know that it's a binomial distribution, because the problem is telling us that you could be O negative or you are not B. So we only have 2 results. And then it told us to construct a probability distribution that, in small words, told us that we made a table to present the data. As we can see, we compute the formula of binomial distribution that we saw some slides later, and we got the probability. Now the B point say find the mean and the standard deviation. So this is quite simple. We use the n that it's equal to 4 and the probability of success multiplied by the probability of success. And then for the variation, we will use the same, but here we will rest 1 to the probability to success. And finally, the standard deviation will be the square root of the number of trails times the probability minus the probability of fails, times the probability of fails. Finally, we have another problem that you could do in your home, or if you want here, I will explain it very fast. And here it is told us that the Clarinex is a medical shows purpose is to reduce the symptoms associated with a variety of allergies in a clinical trials of the 5% of the patients is studied experience insomnia as a side effect. A random sample of 10 is obtained, and the number of patients who experience insomnia is recorded. So here, another time, we only could have 2 results, that the people have this insomnia effect or they don't have this side effect. But here the important thing is that it is telling us to find the probability between 1 and 4 patients. So here we need to compute each probability as in the last problem. That could be better if we do it in a table, and then we sum each probability since 1 until we reach 4, as we can see here. And this sum will give us the probability that in this interval the people get experience insomnia. So thanks for your attention. This is all for today, and I hope that this information helped you.